On March 4, 1918, the U.S. Navy collier USS Cyclops vanished without sending a distress signal, becoming one of the largest unexplained losses in naval history. The ship, commissioned in 1910, measured over 500 feet long and served as one of the Navy's primary coal transport vessels during World War I operations. Records show that Cyclops carried 10 800 tons of manganese ore and a crew of 309 when it departed from Barbados on its final voyage toward Baltimore. Official logs indicate that the ship maintained normal operations during its stay in Barbados, with no mechanical issues serious enough to prevent departure. Communications from port authorities confirm that Cyclops showed no signs of distress or instability at the time of departure on March 4. The vessel's disappearance occurred in the stretch of the Atlantic, commonly associated with maritime losses, later linked to the region known as the Bermuda Triangle. However, U.S. Navy records do not attribute the disappearance to supernatural causes, focusing instead on documented structural, environmental, and operational factors. Cyclops operated under the command of Lieutenant Commander George Worley, whose leadership later drew scrutiny due to conflicting witness testimonies. Crew statements collected prior to the voyage described disciplinary issues and concerns about the captain's temperament, though no direct link to the loss was established. Navy reports confirm that Cyclops was last sighted off the coast of Barbados, but no verified sightings occurred after it sailed north into open waters. The ship carried no wireless distress messages during the voyage, leaving investigators without final position reports or last-minute communications. Weather archives indicate that the region experienced moderate conditions during the relevant period, with no major storms recorded along expected travel routes. The absence of debris, bodies, or recovered cargo added to the mystery, leaving investigators without material evidence to support prevailing theories. The U.S. Navy classified the loss as cause unknown, acknowledging that no conclusive data existed to determine what happened after Barbados' departure. Engineers reviewing Cyclops' maintenance records noted earlier structural concerns, including a cracked engine cylinder that required attention before the voyage. Further inspection logs documented hull stress from previous transits, although reports stated the ship remained seaworthy at the time of departure. Navy Board inquiries later assessed whether overloading contributed to structural weakness, as the manganese cargo was denser than typical operational loads. Investigators analyzed whether the cargo could have shifted during rough seas, potentially destabilizing the ship and causing rapid capsizing. However, no evidence confirmed weather conditions strong enough to trigger catastrophic stability loss, leaving the theory unresolved. The U.S. Naval History and Heritage Command later reviewed archival correspondence but found no additional signals or information sent by Cyclops during its final route. As wartime tensions persisted, early speculation included enemy action, though naval intelligence found no German submarine records supporting this claim. German naval logs, declassified after the war, contained no entries referencing an attack on Cyclops or engagement with a vessel of similar size. This eliminated one of the earliest hypotheses and redirected analysis toward mechanical failure, cargo instability, or structural collapse. The disappearance remains the largest non-combat loss of life in U.S. Navy history, with all 309 personnel unaccounted for and no wreckage ever located. The case's significance led to multiple reinvestigations over the decades, each reviewing available data for potential overlooked factors. Despite extensive archival research, the U.S. Navy maintained its official position. The disappearance occurred under unknown circumstances with no surviving evidence. Researchers continue to examine environmental data, ship design, maintenance logs, and navigational records to understand how such a large vessel could vanish entirely. Following the disappearance, the U.S. Navy initiated an extensive investigation, reviewing logs, communications, and maintenance records from Cyclops' final months. Search operations covered thousands of square miles along the vessel's expected route, yet no lifeboats, cargo, or structural debris were ever recovered. Navy reports document that multiple ships were diverted to scan the region, but none detected oil slicks, floating wreckage, or distress markers. The absence of physical evidence complicated early efforts to determine whether Cyclops suffered a sudden mechanical failure or a gradual deterioration. Investigators examined records showing that the ship's starboard engine had been operating with a cracked cylinder since late 1917, though engineers deemed it manageable. Maintenance logs confirmed that only one engine was fully operational during portions of the voyage, reducing maneuverability but not rendering the ship unseaworthy. Analysts assessed whether single-engine operation increased vulnerability in adverse conditions, yet weather data from early March showed no severe storms. Historical climate archives indicate that the vessel passed through an area known for unpredictable swells, though no reports indicated conditions capable of sinking a steel ship. Navy engineers also evaluated whether structural fatigue contributed to the loss, as Cyclops had transported heavy ore cargo on repeated voyages prior to the incident. The manganese ore loaded in Brazil before the final journey was significantly denser than coal, placing additional stress on the ship's holds and support beams. Investigators studied the possibility of cargo shifting if the ship encountered uneven seas, which could produce a rapid, catastrophic list leading to capsizing. However, without wreckage or survivor accounts, the Board of Inquiry could not determine whether a stability failure occurred. Attention also turned to the ship's commanding officer, Lieutenant Commander George Worley, whose leadership had drawn concern from both crew and supervising officers. Statements collected before the voyage referenced disagreements, morale issues, and disciplinary disputes, though none indicated imminent danger to the ship's operation. Navy reviews concluded that while leadership concerns existed, no evidence linked command issues directly to the disappearance. Wartime suspicion initially pointed toward possible enemy engagement, as German U-boats operated across the Atlantic in 1908 during unrestricted submarine warfare. However, post-war examination of German naval logs revealed no recorded attacks on the date or region where Cyclops would have traveled. The German Admiralty confirmed that no submarine reported sinking or engaging a vessel matching the description of Cyclops. This eliminated enemy action as a plausible cause, redirecting analysis toward environmental or mechanical explanations supported by available records. Investigators next considered the possibility of an onboard explosion, evaluating whether cargo interaction or coal dust residue might have triggered combustion. Cyclops carried no coal on its final voyage, and manganese ore is non-flammable, reducing the likelihood of a chemical or cargo-based detonation. Engine logs showed no indication of hazardous buildup, and the absence of floating debris made an explosion theory difficult to substantiate. With natural disaster, sabotage, and enemy action largely excluded, the Navy acknowledged that the cause of Cyclops' disappearance remained undetermined. Archival correspondence shows that officials described the loss as without a trace, referencing the complete lack of physical or radio evidence. The silence of Cyclops' wireless system remains one of the most significant mysteries, as the ship carried equipment capable of transmitting distress signals. Navy technicians reviewing the logs noted no mechanical issues with the wireless set before departure, raising questions about why no signal was sent. Some analysts proposed that a sudden catastrophic event, such as structural collapse or immediate capsizing, left no time for communication. This theory aligned with the absence of debris, suggesting a rapid sinking in deep waters where recovery would be unlikely. Charts of the region show multiple deep-sea trenches along Cyclops' probable route, capable of concealing wreckage beyond the reach of early 20th century technology. Decades later, marine researchers continued to reference these deep-water zones when evaluating potential wreck locations for future exploration. Despite repeated reviews of all known data, the Navy's final conclusion remained unchanged. The USS Cyclops vanished under unknown circumstances and was never found. In the aftermath of the disappearance, the U.S. Navy compared Cyclops' loss with the operational history of its two sister ships, USS Proteus and USS Nereus. Both vessels were constructed with similar dimensions and structural design, offering investigators a reference point for evaluating potential systemic weaknesses. Navy engineers reviewed stress reports from all three ships, noting that each had carried heavy cargo loads across long ocean routes during wartime operations. Historical records show that both Proteus and Nereus later disappeared under comparable circumstances during World War II, intensifying scrutiny of their shared design. These parallel losses suggested structural vulnerabilities that might have affected Cyclops, though technical documentation remained inconclusive. Researchers examining archival blueprints identified that the ship's longitudinal framing could experience strain under dense cargo such as ore or metallic materials. Cyclops's final load of manganese ore exceeded typical cargo density, prompting questions about whether stress fatigue contributed to a sudden hull failure. Investigators also studied stability reports showing that dense cargo, if improperly secured, could create rapid shifts in weight distribution during rough seas. Such a shift could produce an immediate and severe list, making recovery impossible and preventing communication via wireless equipment. Navy correspondence from 1918 emphasized that cargo securing methods varied by port and crew, making it difficult to confirm loading conditions on the final voyage. Port records from Rio de Janeiro documented the loading process, but did not include detailed accounts of weight distribution across the ship's holds. These gaps in documentation left investigators without definitive evidence to determine whether cargo movement contributed to the disappearance. Attention then turned to navigational records, which indicated Cyclops likely traveled along established shipping lanes between Barbados and the U.S. East Coast. Although the region was known for unpredictable swells and strong currents, no meteorological reports indicated severe weather along the expected route. Climatological data collected from nearby vessels confirmed moderate conditions, further complicating theories that pointed toward environmental factors. Navy analysts also reviewed seismic activity records, exploring the possibility of undersea disturbances along the mid-Atlantic ridge. However, no events were recorded in early March 1918 that could explain the sudden loss of a steel-hulled vessel of Cyclops size. Investigators considered whether the ship may have deviated from its expected path, though no evidence supported unauthorized changes to the navigational plan. Without wireless communication logs, researchers were unable to verify the ship's final heading or speed during the last hours of its voyage. The absence of transmission puzzled analysts, as protocol required distressed vessels to signal even under rapidly deteriorating conditions. This silence supported the theory that the ship encountered an immediate and catastrophic failure, leaving no opportunity to issue a distress call. Further archival review uncovered correspondence noting that the ship's coal bunker partitions had shown signs of wear on previous voyages. These partitions played a crucial role in maintaining structural integrity. Failure in these components could create internal collapse during heavy loading. Despite these concerns, inspections prior to departure did not identify conditions severe enough to warrant withholding the ship from service. Some researchers hypothesized that cumulative structural fatigue, combined with the unusually heavy ore load, could have triggered a sudden hull breach. Such a breach occurring below the waterline would allow rapid flooding, overwhelming bulkheads, and causing a near instantaneous sinking. The extreme depth of waters along the vessel's probable route meant wreckage could descend thousands of feet beyond the reach of early 20th century search methods. Archival historians later emphasized that technology of the era provided no means for deep-sea recovery or acoustic detection of sunken vessels. This limitation persisted for decades, leaving the Cyclops' fate tied to incomplete records, fragmentary testimony, and unverified maritime clues. Although numerous analyses were conducted over the years, investigators consistently concluded that insufficient evidence prevented any definitive explanation. Cyclops' disappearance remained one of the most perplexing maritime losses in Navy history, prompting continued review each time new archival material was uncovered. As decades passed, naval archivists continued to review shipyard records, crew reports, and engineering analyses to identify overlooked details regarding Cyclops' disappearance. One area of focus involved metallurgical assessments of ships built during the same period, examining whether steel quality variations could have influenced structural integrity. Construction logs from 1910 indicated the Cyclops used standard naval steel for the era, though some batches displayed inconsistencies later noted in sister ship evaluations. Researchers found that prolonged exposure to heavy loads, combined with repeated Atlantic crossings, could weaken support frames in older colliers. Cyclops had completed numerous long-distance voyages carrying coal and ore, contributing to cumulative stress across the ship's hull. Review panels noted that structural fatigue often remained undetected until severe conditions triggered a critical failure. The possibility of a sudden hull fracture became one of the leading theories among engineering analysts familiar with early 20th century ship construction. Marine historians later highlighted that the manganese ore aboard Cyclops could compact into a rigid mass, increasing stress along lower hull sections. If a fracture occurred in deep waters, flooding might have overwhelmed compartments too rapidly for broadcasting distress signals. Navy inquiries also evaluated whether the ship's dual-purpose ballast and cargo holds contributed to instability when transporting dense materials. Documentation suggested that improper distribution of manganese ore could create uneven pressure points, increasing susceptibility to sudden shifts. Shipping logs from Barbados indicated that Cyclops took on additional fuel and supplies, but did not detail crew observations regarding cargo behavior. The lack of detailed cargo measurements limited investigators' ability to model potential stability scenarios with precision. While environmental records showed no severe storms, historians noted that even moderate swells could destabilize a vessel heavily loaded with dense cargo. Continued analysis by naval engineers emphasized that the combination of structural fatigue and cargo dynamics remained a plausible explanation. Another investigative focus involved inquiries into whether navigational hazards influenced the ship's route. Maritime charts revealed that deep trenches and abrupt topographical drops along the Atlantic Sea floor could conceal wreckage beyond detection. Submarine canyons in the region reached depths exceeding early sonar capabilities, preventing effective mapping during initial search operations. Studies conducted in later decades illustrated that large steel vessels could sink intact into these trenches, leaving minimal surface evidence. Given the limited technology of 1918, search vessels lacked both acoustic sensors and deep-sea exploration equipment needed to locate submerged wreckage. Historical reviews emphasized that the lack of modern detection systems significantly hindered search operations, contributing to the mystery surrounding the loss. In addition to structural and environmental assessments, investigators analyzed correspondence concerning the ship's commanding officer, George Worley. Reports prior to the voyage describe leadership conflicts, but the Navy found no evidence indicating deliberate deviation or misconduct related to the disappearance. Further examination of personnel records revealed that while some crew members expressed dissatisfaction with command decisions, none described conditions suggesting operational peril. Navy inquiry boards concluded that leadership issues did not contribute materially to the vessel's loss based on available documentation. Intelligence analysts during World War I initially considered the possibility of enemy action, though this theory was dismissed following post-war review of German naval archives. German U-boat commanders kept detailed logs of engagements, and no entries referenced a vessel resembling Cyclops or an attack in the region during early March 1918. This confirmation eliminated armed conflict as a viable explanation, strengthening the hypothesis of mechanical or structural failure. Subsequent historical studies suggested that rapid sinking scenarios, particularly those involving cargo shifts or hull fractures, aligned best with the absence of debris. Theories involving slow deterioration were viewed as less probable, as they would likely have provided time for distress communication. The Navy's final assessment reiterated that Cyclops's loss occurred suddenly, leaving no opportunity for signaling or evacuation. Despite continued research, no definitive evidence emerged, and the ship's disappearance remained an unresolved maritime case. Its legacy persisted as investigators, historians, and naval engineers used the Cyclops case to inform future analyses of unexplained vessel losses. In the decades following the loss, the U.S. Navy revisited Cyclops' disappearance during broader reviews of maritime incidents involving coal and ore carriers. These assessments sought to determine whether the vessel's design or cargo handling practices contributed to risks that were not fully understood in 1908. As part of this review, investigators compared Cyclops with her sister ships, Proteus and Nereus, both of which vanished in the Atlantic under similar conditions decades later. The loss of these three nearly identical vessels prompted renewed scrutiny of their structural integrity and potential weaknesses inherent to the class. Naval engineers analyzed ship plans, noting that the aging colliers relied on longitudinal framing that experienced high stress under repeated heavy cargo loads. Repeated voyages carrying dense materials such as ore could accelerate metal fatigue, particularly in areas where stress concentrations developed along hull plates. Maintenance logs from comparable ships reveal signs of wear in bulkheads and support beams, suggesting that undetected stress fractures were not uncommon. Cyclops's final cargo, consisting of over 10,000 tons of manganese ore, presented additional challenges due to its density and potential for uneven settling. Researchers evaluated whether cargo compaction created localized pressure points capable of triggering hull deformation during sharp maneuvers or sudden swells. Without precise loading records from Barbados, investigators could not determine whether the cargo was optimally distributed across the ship's holds. Historical analyses suggested that uneven distribution might have compromised stability, increasing vulnerability to sudden imbalance in rough waters. However, weather reports from early March 1918 documented moderate conditions, offering no evidence of a storm capable of producing extreme instability. This discrepancy left researchers uncertain whether cargo factors alone could account for the rapid sinking implied by the absence of distress signals. Attention then turned to fuel records and ballast adjustments made prior to the vessel's departure from Barbados. Fuel logs indicated that Cyclops loaded coal for auxiliary power, though this did not significantly alter overall weight distribution due to the overwhelming mass of ore. Navy analysts considered whether ballast adjustments may have been insufficient to counterbalance the dense cargo, though documentation remained too limited for certainty. Further examination of archival correspondence found no evidence that crew members expressed concern about stability prior to departure. The lack of reported issues reinforced the theory that if failure occurred, it likely happened abruptly and without preceding warning signs. Researchers also investigated whether metallurgical inconsistencies played a role in weakening hull sections over time. Steel produced in the early 20th century varied widely in composition, and some batches displayed brittleness when subjected to cyclical stress. Analysis of sister ship failures suggested that structural fatigue may have developed invisibly until a critical point triggered sudden collapse. Given the depth of waters along Cyclops's probable route, even a brief structural breach could have caused a rapid descent into deep-sea trenches where recovery was impossible. The absence of floating debris suggested that the vessel may have remained largely intact as it sank, carrying its cargo and crew to extreme depths. Modern researchers examining historical sonar surveys noted that vast sections of the Atlantic remain unmapped, leaving potential wreck locations unidentified. This technological limitation underscores why Cyclops has avoided detection despite numerous search efforts conducted over the last century. The U.S. Navy archival records consistently emphasize that no verified sighting, signal, or distress call was received after the ship left Barbados. This silence remains one of the most significant characteristics of the case, indicating that the final event occurred too swiftly for any response. Investigative panels assessing similar maritime losses concluded that sudden catastrophic structural failure aligns most closely with the available evidence. However, without physical wreckage, the Navy maintains that multiple scenarios cannot be conclusively ruled out. The disappearance of Cyclops continues to be studied in naval training programs as an example of how incomplete records and technological limits can hinder post-incident analysis. Historians emphasize that the event highlights the need for thorough structural assessments and standardized cargo handling procedures in modern maritime operations. Cyclops' legacy remains preserved in Navy reports, maritime archives, and historical analyses that document its significant role in shaping subsequent safety evaluations. As research broadened in later decades, analysts reviewed communication logs from nearby vessels operating along Cyclops' expected route in early March 1918. These ships reported standard navigational conditions with no recorded signals indicating distress or unusual maritime hazards in the region at the time. The absence of contact reinforced the conclusion that Cyclops did not broadcast warnings or requests for assistance before vanishing. Wireless communication records from coastal stations also showed no intercepted transmissions consistent with emergency messaging from the ship. Given the technology of the era, even damaged vessels typically attempted to signal distress, making Cyclops' silence a focal point in later analyses. Investigators considered whether the ship's wireless antenna or generator might have failed, but maintenance reports indicated no significant issues prior to departure. Navy reviews stressed that even partial communication systems could usually transmit short-range signals, yet none were detected across listening stations. This unusual silence suggested that whatever occurred happened so quickly that communication became impossible. Historical studies of similar maritime incidents revealed that instantaneous capsizing or sudden hull breach events often prevented crews from sending warnings. Cyclops' massive cargo load and structural fatigue made such scenarios plausible, especially if failure occurred below the waterline. Additional archival research explored whether navigational errors could have led the ship into hazardous areas not documented on charts of the time. Maritime logs from other vessels indicated strong currents along parts of the route, yet none reported conditions capable of overwhelming a steel collier. Although the region includes deep trenches, navigational charts did not show obstacles likely to cause immediate catastrophic damage. Investigators also evaluated whether the ship might have encountered an uncharted weather disturbance, though barometric records offered no supporting data. Meteorological archives from Caribbean and Atlantic monitoring stations showed stable atmospheric conditions with no significant storm activity. The lack of environmental triggers reinforced the theory that internal structural failure remained the most credible scenario. Further reviews examined fuel records and the operational load placed on the ship's remaining functional engine during the final voyage. Single-engine operation placed additional strain on maneuvering capabilities, but was considered within operational limits according to Navy standards. However, limited propulsion capacity may have made it more difficult to correct sudden listing or respond effectively to unexpected shifts in cargo. Engineering analyses emphasize that in a fully loaded vessel, even slight delays in corrective maneuvers could lead to accelerated instability. The possibility of progressive flooding was also explored, though investigators noted that such scenarios typically allow time for distress signaling. Rapid flooding caused by structural collapse would better align with the lack of communication and the complete absence of floating debris. Researchers then turned to human factors, reviewing crew rosters and examining whether any personnel issues could have compromised operations. Personnel records indicated a diverse crew with varying levels of experience, though no documentation suggested misconduct or operational negligence. Interviews conducted before departure recorded minor grievances, but nothing indicating conflict severe enough to affect navigational safety. Navy reviewers concluded that human error, while always possible, lacked supporting evidence and therefore could not be identified as a contributing factor. Attention later shifted to the ship's wartime context, exploring whether Cyclops might have altered course for security reasons or under classified directives. Archival correspondence offered no indication of special routing orders or clandestine cargo that could have influenced its operational decisions. Without navigational updates or survivor testimony, uncertainty persisted regarding the precise path taken after the ship left Barbados. Historical researchers underscored that unknown deviations could place the vessel in regions where depth and seafloor topography made detection nearly impossible. Late 20th century sonar surveys provided partial mapping of the Atlantic basin, but left large stretches unexplored, limiting wreck identification efforts. The Navy has stated repeatedly that no confirmed wreckage matching Cyclops has ever been found despite multiple search initiatives over the decades. These continued absences uphold the case as one of the most enduring maritime mysteries in U.S. naval records, sustained by incomplete data and impossible to recover evidence. As historical interest grew, researchers conducted comparative analyses with other wartime shipping losses to determine whether Cyclops fit identifiable maritime patterns. Most vessels lost during World War I left evidence such as debris fields, oil slicks, or survivor accounts, distinguishing Cyclops as an outlier. The absence of any physical trace elevated the case to a subject of long-term naval investigation and academic study. Naval historians emphasize that Cyclops' disappearance predated widespread deep-sea search capabilities, limiting recovery despite extensive early efforts. Throughout the 20th century, advancements in sonar and underwater imaging prompted renewed proposals to search for the missing vessel. However, the ship's wide possible search area, shaped by a lack of final position data, complicated planning and reduced the likelihood of discovery. Oceanographic studies of the Atlantic basin indicated that much of the seafloor remained unmapped, including regions with depths exceeding 20,000 feet. Such depths pose significant challenges for exploration, even with modern equipment, making any targeted search highly uncertain. Researchers examined whether natural geological features could have concealed the wreck, including steep drop-offs, sediment layers, and underwater canyons. These features had been documented to obscure large wrecks, demonstrating how a ship the size of Cyclops could descend into inaccessible terrain. Investigators also reviewed archival insurance documents, which included assessments of the ship's condition prior to its final voyage. These assessments noted aging components but did not identify faults severe enough to question its seaworthiness under normal operational conditions. The cargo manifest from the final voyage confirmed the presence of manganese ore, which has a high density that could influence ship behavior under stress. Analysis later suggested that if the vessel experienced even moderate rolling, cargo movement might have intensified internal pressure on hull frames. Historical simulations conducted decades later modeled how ore might shift within the holds, creating asymmetrical loading capable of destabilizing the ship. Such simulations supported the hypothesis that cargo shift, in combination with structural fatigue, could lead to immediate capsizing. However, without wreckage, these models remained theoretical, offering only potential explanations rather than definitive conclusions. Naval inquiries reviewed crew experience records to evaluate whether training levels played a role in emergency preparedness. Although crew composition varied, personnel had completed multiple voyages and were familiar with standard operational procedures for coal and ore carriers. Training logs did not indicate deficiencies that would significantly increase the likelihood of operational errors during routine navigation. Historical reviews emphasized that even well-trained crews could not respond effectively to sudden catastrophic failure, explaining the absence of distress signals. In later decades, researchers examined Cyclops' disappearance in connection with its two sister ships, both of which vanished under similar circumstances. The parallel losses reinforced theories involving structural vulnerabilities inherent in the class design rather than location-specific hazards. Proteus and Nereus were lost during World War II, also while transporting heavy cargo in the Atlantic, and neither produced debris or survivors. This pattern suggested that design limitations, material fatigue, or cargo-related stress could contribute to sudden failure among these vessels. Naval architects analyzing the trio of losses proposed that hull framing may have been insufficient to withstand prolonged exposure to dense cargo loads. The possibility of design-related stress points aligned with documented maintenance concerns observed in each of the ship's operational histories. Although these findings strengthened theories related to structural failure, they did not conclusively determine what happened to Cyclops. By the time modern search technologies became available, decades of shifting currents and sediment accumulation had further complicated potential wreck identification. The U.S. Navy repeatedly confirmed that no definitive wreck site had been located and that all known theories lacked verifiable physical evidence. Historians concluded that Cyclops' disappearance remained within the realm of documented maritime uncertainties, shaped by limited records and unrecoverable evidence. As maritime research progressed into the late 20th century, investigators leveraged expanding datasets to reassess Cyclops' disappearance using updated analytical methods. Oceanographers reviewed current patterns and drift models to estimate where debris might have traveled had any remained afloat following the ship's loss. These models suggested that floating materials would likely have dispersed rapidly across broad sections of the Atlantic, yet no such debris was ever reported. The absence of flotation evidence reinforced hypotheses involving sudden and complete submersion rather than gradual sinking or surface-level breakup. Deep-sea mapping projects provided further insights by revealing trench networks along the vessel's probable route, capable of concealing large wrecks for decades. These underwater formations included vertical drops exceeding early sonar detection capabilities, complicating search operations during initial investigations. Modern researchers noted that ships descending into such depressions often remain undetected due to sediment buildup and challenging topography. This environmental context aligned with the historical absence of wreckage and helped explain why Cyclops has never been located, despite extensive study. Archival reviews also examined communication regulations of the period to determine whether wireless protocol might explain the ship's silence. In 1908, wireless operators were instructed to maintain regular equipment checks, and logs from prior voyages showed compliance aboard Cyclops. Investigators found no record of malfunction before the final departure from Barbados, suggesting communications equipment was functional. The lack of distress signals therefore pointed strongly toward an instantaneous incident, leaving no opportunity for the crew to engage emergency procedures. Further research into crew accounts from earlier voyages indicated concerns about hull vibrations when transporting dense ore loads. These vibrations were noted in inspection reports, though they did not prompt structural restrictions or mandate additional reinforcements. Historians later emphasized that knowledge of metal fatigue was limited at the time, making potential stress accumulation difficult to assess accurately. Examination of ore handling procedures revealed that loading practices could vary significantly from port to port, potentially creating uneven cargo distribution. Uneven loading could intensify stress on weakened structural sections, generating instability if the vessel encountered even moderate wave patterns. While this theory aligned with engineering assessments, supporting documentation remained insufficient due to limited cargo records from the Barbados stop. Investigative efforts also evaluated whether the ship may have encountered a sudden mechanical failure unrelated to hull integrity. Engine maintenance reports documented ongoing issues with a cracked cylinder, though engineers deemed the vessel operable and seaworthy. Single-engine operation could reduce maneuverability, especially in response to unexpected shifts in cargo or rapid listing. However, mechanical failure alone could not fully explain the absence of debris or the lack of transmitted alerts. As historians continued their analysis, they incorporated data from global maritime incidents to determine how Cyclops fit within broader ship loss patterns. Records showed that vessels experiencing sudden catastrophic failure in deep waters often left no trace, especially when carrying dense cargo. This pattern aligned with potential explanations for Cyclops' disappearance, particularly if structural failure occurred below deck. Theories involving external threats, including sabotage or enemy engagement, remained unsupported due to lack of documentation or corroborating evidence. Post-war German naval logs consistently affirmed that no submarine activity matched Cyclops' route or timeline. Archival intelligence reviews found no indication of clandestine operations or classified cargo aboard Cyclops that might alter established theories. Throughout decades of examination, researchers repeatedly emphasized the central challenge: the absence of physical evidence prevented definitive conclusions. All surviving theories remain grounded in documented factors such as structural fatigue, cargo dynamics, mechanical limitations, and environmental conditions. The U.S. Navy has stated that the case exemplifies the complexity of maritime investigation in an era before modern navigation, communication, and detection tools. Despite advances in deep-sea exploration technology, the likely depth and location of any potential wreck site make future discovery uncertain. Cyclops persists as one of the most enduring mysteries in naval history, shaped by incomplete records and the vast, inaccessible terrain of the Atlantic Ocean. Over time, the disappearance of USS Cyclops evolved from a wartime loss into a major subject of historical and naval analysis, representing one of the most documented unexplained incidents in U.S. maritime history. Researchers continued examining every available source: official logs, port records, maintenance documents, and meteorological archives to assemble a coherent timeline of events. The consistency of all records confirming normal operations prior to departure deepened the mystery rather than resolving it. Investigators repeatedly emphasized that no sign of mechanical distress, navigational deviation, or external threat was reported during the ship's final moments in port. This left the ultimate cause centered on possibilities that could occur suddenly and without warning, preventing communication and leaving no surface remains. Deep-sea scientists studying the region reinforced that the Atlantic Basin contains trenches deep enough to obscure major wrecks beyond the reach of conventional search equipment. These geological features created conditions where a large steel vessel could descend rapidly and remain undetected for more than a century. Historical sonar surveys lacked the resolution to identify objects buried beneath layers of sediment, further reducing the likelihood of locating Cyclops. Modern mapping initiatives have improved coverage, but vast sections of the ocean floor remain unmapped, preserving the possibility that the ship rests in unexplored terrain. Maritime analysts highlighted the unusual nature of losing a vessel as large as Cyclops without leaving a trace, yet they acknowledged numerous documented cases where similar conditions led to complete disappearance. In the case of Cyclops, the combination of dense cargo, cumulative structural fatigue, and deep water geography created a scenario that aligns with known patterns of catastrophic maritime failure. The continued examination of sister ship losses strengthened the hypothesis that design-related vulnerabilities contributed to their fates. The disappearance of Proteus and Nereus under similar circumstances suggested that structural limitations within this ship class may have played a role in Cyclops' loss. However, the absence of physical evidence prevented any definitive conclusions, leaving each theory supported only by available documentation and technical analysis. The U.S. Navy's official position has remained unchanged throughout successive reviews. The ship vanished under unknown circumstances with all 309 lives lost. This designation reflects the limitations imposed by missing communication records, the vastness of the search area, and the lack of recoverable material evidence. Archival research underscores that Cyclops was never engaged in classified or covert operations during its final voyage, dismissing theories of concealed missions or secrecy-driven explanations. Records confirm the vessel was transporting manganese ore, a strategic wartime material, under routine naval orders with no indication of irregular activity. Historians examining the disappearance have emphasized that extraordinary claims lacked support and that available evidence aligns with documented maritime risks of the era. The disappearance has often been associated with sensational theories, but official investigations consistently rejected conclusions unsupported by empirical data. Instead, the case stands as a reminder of the procedural and technological limitations faced by early 20th century naval operations. Search capabilities of the era were insufficient to monitor deep-sea environments, leaving investigators reliant on incomplete surface-level observations. Modern researchers continue to study Cyclops' loss to inform discussions about risk management, vessel design, and the evolution of maritime safety procedures. The event underscores the importance of detailed cargo handling records, thorough structural assessments, and redundant communication systems. Cyclops' disappearance remains a focal example used in naval training programs to highlight analytical challenges presented by incomplete documentation. Although numerous attempts have been made to identify potential wreck sites using modern sonar, none have produced verified evidence of the ship's location. The legacy of Cyclops endures not through unresolved speculation, but through documented efforts to understand the technical and environmental factors that shaped its fate. As with many maritime mysteries, the ship's final resting place may remain unknown, concealed by the depth, geography, and natural processes of the Atlantic Ocean. Yet the extensive archival record ensures that the disappearance continues to be studied, preserving the historical significance of the Navy's vanishing giant. More than a century after USS Cyclops vanished, the case remains one of the most enduring unsolved losses in American naval history. Every official investigation conducted across multiple generations of analysts, historians, and naval engineers has reached the same conclusion: the cause cannot be determined with the evidence that survives. No distress signal, no wreckage, and no verified sighting have ever surfaced to clarify what happened after the ship departed Barbados in March 1918. Theories grounded in available records point toward structural fatigue, cargo instability, or sudden catastrophic failure, yet none can be confirmed without physical evidence. Deep trenches along the Atlantic seafloor provide a plausible explanation for why the ship has never been found, as depths far beyond early 20th century search capability could easily conceal a vessel of its size. The disappearance of Cyclops, and later the loss of her sister ships, prompted long-term reevaluation of cargo handling, ship design, and naval safety protocols. More importantly, it demonstrated the limitations imposed by incomplete records and the technological constraints of the era. Today, Cyclops stands not as a myth, but as a documented maritime tragedy defined by uncertainty rather than speculation. Historians continue to examine surviving evidence, yet the Atlantic has kept it secret, leaving the final chapter of USS Cyclops unwritten. What remains is a legacy of unanswered questions and the enduring reminder that even the largest ships can vanish without a trace when conditions align beyond human control.